Hey everybody, so in this video we're going to talk about solving radical equations. Okay, you should have some experience with this from your Algebra 1 class, so we're going to focus on more complicated examples than the basic ones. Okay, so let me remind you of how we would solve these. Okay, the first thing you want to do is isolate the radical. Okay, or if there's more than one, you want to isolate one of them. Okay, then the second thing you want to do is square both sides to get rid of the square root. Okay, now this is something that should seem familiar to you because this is what we were doing with the other types of radical equations, like when we had cube roots and fourth roots. This is the process that we were doing. Isolate the radical and then use the appropriate power. Because we're talking about square roots here, then squaring is the power that we would use. Okay, now step 3, you're only going to do this if necessary. Okay, so we're going to repeat those steps. If we still have a square root. Okay, so if after steps 1 and 2 you still have a square root, you repeat those steps. Isolate that root and then square again. Okay. Then the fourth thing we're going to do is finish solving. Okay, and the last thing we're going to do, and this is not an optional step, this is a necessary step, is we are going to check for extraneous solutions. Okay, and we'll talk about what extraneous solutions are just here in a second. Okay, so that's our process for solving. Okay, so like I said, before we even do an example, let's talk about what extraneous solutions are and how we check for them. Okay, so an extraneous solution is something that you get from solving correctly. I want to stress that. It is not something that you get from making a mistake. It's something that you get naturally in certain situations, even though you've solved correctly. Okay, but when you substitute it back into the original equation, a real solution will give you a true statement, right? That's what makes something a solution. When you plug it into the equation, you get something true. But an extraneous solution will give you something false, okay? So these extraneous solutions are not solutions to the equation. They're fake solutions. They come from solving correctly. They look like a solution, but they're really not, okay? The only way to check for extraneous solutions is to plug back into the original equation. You can't detect them in other ways. Okay, so let's do an example of solving, and then we'll do an example of how you check your solutions to see if they're extraneous. Okay, So like I said, we should have seen the basic examples for this already, okay? If you have not seen them, go ahead and watch the extra video that I posted for you guys, but we're gonna start with a little bit more complex examples. Okay, so for this example, we can see that the first step of isolating the radical is already done. We have already isolated the radical, okay? Then the next thing we're gonna do is square both sides to get rid of the square root, okay? It is important that when you square this side, because there's more than one term, you are squaring the whole thing. Okay, we are also squaring the whole thing over here. It's just that this is all under the radical, so it's easy to see when you put the square that you're squaring the whole expression. Okay, now over here, remember that when you're squaring these, right, you're doing them times themselves like this. Okay, and over here, the square root and the square are going to cancel, and we just end up with the radicand 40 minus 3x. Okay. Now, I'm going to multiply this out. I get 4x squared minus 10x minus 10x plus 25. Okay, so that's my first two steps. I've isolated the radical. That was already done in this problem. Then I've squared both sides. Okay. Now, because I have an x squared term, oh, I wanted to mention that I don't need to repeat those steps because there's no square roots left in my expression. Okay, so I'm going to move on to our fourth step, which was finish solving. Now, I have an x squared here, which means that I want to do an x squared type of solving, right? Now, we did spend a lot of time solving quadratic equations, right? So we're first going to try factoring, and then if that doesn't work, we'll try the quadratic formula. Okay, so I'm going to gather all of my terms together on the left side so that I can try to solve using factoring. So this would be minus 20x, and then adding 3x would be minus 17x. Okay, and then 25 minus 40 is going to be minus 15. Okay. Now I'm going to try to factor this. Okay. I'm going to start with 2x and 2x. Okay. And then what multiplies to 15? Well, 5 and 3, so maybe I'll try 5 minus 5 and plus 3. This would give me negative 10 and positive 6. That doesn't work. Okay, so let me try 4x and x. Okay, so I'll try again minus 5 and plus 3. This is minus 20 plus 3, and that's minus 17, so this works. Okay, set each of my factors equal to 0. Okay, and get my two solutions, x equals 5 and x equals minus 3/4. Okay, so that is the finish solving part of this expression, or of this process. Okay, so we squared both sides, we ended up with a quadratic, so we solved it by factoring. Okay, and now we are going to check for extraneous solutions. Okay, so like I said at the very beginning, there is no way to check other than to just plug them back in. So remember, this was our original equation. Okay, so we're going to check our two solutions. Okay, we're going to check x equals 5. Okay, so I would plug in 5. Okay, so 2 times 5 is 10, minus 5 is 5. Okay, 40 minus 15 is 25. Okay, so that's true. This is a real solution to our equation. Okay, so I'm going to go ahead and circle this, right? This is really an equation or a solution to my equation. Okay, then I'm going to check x equals negative 3/4. Okay, so I have 2 times negative 3/4, okay, minus 5, equals the square root of 40 minus 3 times 3/4. Okay, now 2 times 3/4, these are going to cancel, and I'll get negative 3/2, okay, minus 5. Okay, and then here I have 40 minus 9/4. Okay. All right, now 5 is the same as 10/2, so this is going to be minus 13/2. Okay, over here, 40 times 4 is 160, okay, minus 9 is, right, 40/1 equals 160/4. Okay, and 160 minus 9 is 151. Okay. Now, the square root of 151 is not an even number, and it certainly isn't 13. Okay, and in any case, this is a positive value while this is a negative value. So this is a false statement, which means that this is an extraneous solution. Okay, so I'm going to write that under my original answer, that this is extraneous. Okay, so here is my real solution, here is my extraneous solution. Okay. All right, now let's see another example like this. Okay, now the first thing I'm going to do is isolate the square root by adding 3 to both sides. Okay, now that I have my square root isolated, I'm going to square both sides. Okay, now when I square this, remember I'm doing x plus 3 times x plus 3. I should get x squared plus 6x plus 9. And over here, the square root and the square will cancel, and I'll get the radicand, negative 3x minus 5. Okay, so that's the first two steps. Isolate the radical, square both sides. Okay, now again, when I go to solve, I can see that I have an x squared, so I'm going to move everything to one side and try factoring. Okay, so when I add 3x to both sides, I'll get 9x, and when I add 5 to both sides, I'll get 14. Okay, now I'm going to factor this. What multiplies to 14 and adds to 9? It should be 7 and 2. Set each of my factors equal to 0. Okay, and get my two candidate solutions, negative 7 and negative 2. Okay, now I still need to check these solutions to see if they're extraneous. Okay, so let's check them. Okay, remember my original equation was this: x equals square root of negative 3x minus 5 minus 3. You can check it here or here. The issue really arises when you square both sides. Okay, so you can't check it in this. They will both solve this equation. You have to check it before you square both sides. Okay, so I'm just going to stick with my very original equation. Okay, so I'm going to check x equals -7. Okay, so plugging in, I would get -7 equals square root of -3x minus 5 minus 3. Okay. So -3 times -7 is 21. Minus 5 is 16. Okay, square root of 16 is 4. Okay, and I get -7 equals 1. Okay, that's obviously false. Okay, so that means that this is extraneous. Okay, now let me check my other equation, or my other solution, which was x equals -2. Okay, so again, I'm going to plug it into the original equation. So x equals the square root of -3 times x, or times x, which is -2, minus 5, okay, minus 3. Okay. So -3 times -2 is 6. 6 minus 5 is 1. Okay, so I get -2 equals 1 minus 3. -2 equals -2. Okay, that's true. Okay, so that means that this is a solution. Okay. Now, in the previous two examples, we've ended up with two answers and got that one is extraneous and one isn't. Okay. I just wanted to point out that that's not always the case. You will sometimes get one answer and it is extraneous. Sometimes you get two answers and they're both extraneous. Sometimes you get one answer and it's really a solution. Sometimes you get one answer, right? It doesn't really, you don't always end up with the case that we just saw where you get two solutions and then one's extraneous and one isn't. Even if you end up with two solutions, you could have the case where they're both extraneous, the ones that we saw where one is and one isn't, or they're both really solutions. Okay, those all three possibilities happen. Okay. All right, let's do another example. Okay, so the first thing we want to do here is isolate one of the two radicals. Okay, so I'm going to add this one to the other side. Okay, now we've actually isolated both radicals, but if that wasn't possible, we would just focus on isolating one of them. Okay, now that we've done that, we're going to square both sides. Okay, now the square roots and the squares will cancel out, right? That was our plan, so we'll get x minus 1 equals 4x minus 3. Okay, now this is not a quadratic equation, this is just a linear equation. So we're just going to subtract x from both sides and then add 3 to both sides. Okay, and then finally divide both sides by 3. So I get x equals 2/3. Okay. Now, we still need to check this to see if it's an extraneous solution. Okay. So we're going to check x equals 2/3. Okay. Even though there's only one solution, we still need to check it. So it's x minus 1, so 2/3 minus 1, okay, minus the square root of 4 times x minus 3 equals 0, okay? So 2/3 minus 1 is negative 1/3, okay? And then 4/3 is, 4 times 2 is 8, so we'll have 8/3 minus 9/3. Okay, so this is going to be square root of negative 1/3 minus square root of negative 1/3, okay, equals 0. Okay, now this is true. Okay, so this is really a solution to this equation. All right, let's do one more example. Okay. Now, it may seem like we need to do something to isolate one of these radicals, but I want to remind you that you can always multiply radicals by multiplying the radicands, right? That's something that we saw in the last section. So we can actually multiply these together and get x squared minus 3x. Okay. Now our radical is isolated and we can move on to squaring both sides. Okay. This side, the square root and the square are going to cancel, so I'll get x squared minus 3x. Okay, 2 squared is 4. Okay, again, I have an x squared type of equation, so I'm going to go ahead and subtract 4 from both sides and try to factor. Okay, now this does factor. What multiplies to negative 4 and adds to negative 3? It should be negative 4 and positive 1. Okay, set each of my factors equal to 0. Okay, and I get two solutions, x equals 4 and x equals negative 1. Okay, now we still have to check these solutions, okay, and we're going to check them in the original equation. So we're going to check x equals negative 4. Okay. Oh, sorry, x equals positive 4. That was my solution. So I had square root of x times the square root of x minus 3 is equal to 2. Well, square root of 4 is 2. 4 minus 3 is 1. Root 1 is also 1. Okay, so this is true. And x equals 4 is a solution. Okay. Then let me check my other solution, x equals negative 1. Okay. I have square root of negative 1 times the square root of x minus 3, okay, equals 2. Okay, so I have root negative 1 times root negative 4 equals 2. Okay, so we have to remember what we know about complex numbers now. Okay, square root of negative 1 is I. Square root of negative 4 is 2i. Okay, multiply these together, we get 2i squared. Okay, I squared is negative 1. Okay, so we can see that this is false. Okay, and this is an extraneous solution. Okay, so this is my solution. This is an extraneous solution. All right. That's all the examples we're going to do in this video. In the next video for this section, we'll go over examples where there are two radicals and there's no way to simplify them. Okay, so I'll see you guys then.